Greetings, ladies and gentlemen. In this video, we will be covering the method of integrating factors. Now, this method can only be used with first-order linear differential equations. Now, most of these differential equations, in this case, they don't even have to be homogeneous. You can even have a function at the end. Now, if any of those words that I said didn't make sense, you can request us to make a video explaining just the vocabulary of differential equations. There are a lot of words that go along with this. Now, method of integrating factors says that you have to put your equation, differential equation, in this particular format. In other words, the coefficient in front of the y is simply a 1. Coefficient in front of this y is in terms of t, or it can simply be a constant, and this is another function in terms of t. Now, method of integration of factors says that you find a mu term and you multiply the entire equation through with mu, okay? And once you do that, you'll see a couple of patterns starting to emerge. Now, let's look at number 1 here. Just rewrite this over here. Y prime minus 2y is equal to t squared e to the 2t. Now, what we would want to do in this case is first off figure out what our mu is equal to, or in other words, what our integrating factor. Now, this is our integrating factor is equal to. So, mu is equal to, this is the function that represents this p of t. Okay? So mu is equal to e to the integral of -2, so p of t dt. Simplifying that, you would end up getting e to the -2t plus c. Now, this plus c constant, we don't need it, so let's just do this. Let's just say let c equals 0, therefore your integrating factor, or mu, would simply be e to the -2t. Now, what you do with this integrating factor is you take this integrating factor and multiply through with the entire equation. All right? Now, I'll actually do that in green right here. So we would end up getting e to the -2t y prime minus 2e to the -2t is equal to e to the -2t t squared e to the 2t. So what I just ended up doing was I ended up multiplying e to the -2t with each and every single term in this equation. Now let's see if we can simplify it before proceeding. And I will do this in blue. So over here, e to the -2t y prime, we can't simplify that. This is fine as it is. Over here, though, we can do something. Now, rules of exponents, when you have the same base and you're multiplying those bases, you would simply want to add the exponents. In other words, -2t plus 2t would give you 0. Therefore, getting e to the 0 times t squared on this side, e to the 0 is simply 1. Any number to the 0 is 1. Therefore, this will just end up being t squared. Let's just rewrite it. E to the -2t y prime minus 2e to the -2t is equal to t squared. Now, here's where the cool part comes in for integrating factors. This piece right here, we can think of this as the derivative of the product rule. Okay? Now, I'll write it like this. I'll say that e to the -2t y, entire expression prime, is equal to t squared. Now, what just happened here? I just said that if you were to take the the derivative of this piece, therefore this prime, would end up getting this particular piece right here. If you don't believe me, take the derivative of this and it will look just like this. Now, how do I know that this factored down into this? Well, once you start doing more of these problems, you'll end up seeing a pattern. And you'll end up realizing that a lot of times it's just y times whatever is in the first piece right here. It may be different, but that's how it is a lot of times. Now, when we're finding a solution to a differential equation, we usually want to take integrals, right? We want to go from derivatives back to original functions. Therefore, let's take the integral of this piece and the integral of this piece with respect to t. Now, the integral and the derivative cancel each other out. They undo each other, essentially. Thus getting e to the negative 2t y is equal to integral of t squared would simply end up being t cubed over 3 plus c. Now, let's just come over here. Come right up over here. Right there. E to the negative 2t y is equal to t cubed over 3 plus c. Now, this in itself is a general solution. However, a lot of times we would want to simplify the general solution, solve it for y. In other words, what we can do is we can divide both sides by e to the negative 2t. Okay? Canceling this out. Now, dividing by e to the negative 2t is the same as multiplying by e to the positive 2t. Now, this goes back to rules of exponents, okay? So, in other words, this would end up being y is equal to e to the 2t times t cubed over 3 plus c e to the 2t. And this is a more simplified version of your general solution than this was. All right? In fact, you can even factor out the e to the 2t. Y is equal to e to the 2t times t cubed over 3 plus c. Okay. This is your general solution. This is what you are essentially looking for. Now, let's go on to example number 2. I'm just going to erase all this. Now, example number 2 is a little bit more complicated. Not as far as the differential equation is concerned, but more in terms of how you're dealing with the calculus. All right, so let me just write this down. Y prime minus y is equal to 2te to the 2t. Now, first step, find the integrating factor. In other words, mu is equal to e to the integral of, well, in this case, our p of t happens to be this constant term right here, negative. In other words, a negative 1. E to the integral of negative 1 dt, which simplifies down into e to the negative t plus c, which is equal to, well, if we let c equals 0, this turns into e to the negative t. All right? So this is our integrating factor. Step number 2. Now I'll just actually put an a over here. Step B is to multiply through the entire equation with this integrating factor term. In other words, we would end up getting e to the negative t y prime minus e to the negative t y is equal to e to the negative t 2t e to the 2t. Now, this piece right here would simplify down into the derivative of the product rule. All right? Now, kind of like what I said last time, a lot of times it ends up being whatever is over here, e to the negative t, times just the y, and simply prime the whole thing. So I took this piece, rewrote it right here, and this ends up being equivalent to this entire expression right here. If you don't believe me, take the derivative of this. Okay? Now, so this is equal to, let's just simplify it right here. Well, simplifying the exponents, this turns into 2t e to the t. I simply, when multiplying the bases, you would simply add the exponents. So this ends up being, let's take the integral of both sides. We end up having e to the negative t times y is equal to 2 times the integral of t e to the t dt. Now I'm just going to write the dt right here too. And all I did was simply pull out a constant term. Okay. Now this one, if you think about it, you can use integration by parts. Now if you have any trouble with integration by parts, let us know, request it in a message, and we will make a video just for integration by parts. So this ends up being u is equal to t, du is equal to dt, dv is equal to e to the t, v is equal to e to the t as well. Okay. So over here I took the derivative of u, over here I took the integral of dv. All right. This simplifies down into, and I'll just rewrite it right here, simplifies down into 2 times u times v, which is t e to the t, minus the integral of v du, in other words, e to the t dt. Now again, this is integration by parts. It's more of a calculus aspect than differential equations, so if you have any questions, let us know. Therefore, we will have, let's simplify this, the integral of e to the t is simply e to the t itself, and let's distribute the 2 inside. Therefore, getting e to the, I'm just going to write this left part right here, e to the negative t times y is equal to 2t e to the t minus 2 e to the t plus c. So far, so good. Next thing I want to do is I can divide by an e to the negative t, or I can multiply through with a positive e to the t, or excuse me, e to the positive t. What that will end up doing is that will get rid of this exponent, getting e to the 0, therefore getting 1, leaving the y by itself, and that's what we want when we're simplifying for the general solution. So let's multiply the left also by e to the t, thereby getting y is equal to, let's simplify, 2t e to the t times e to the t, simply add the exponents, e to the 2t minus 2 e to the 2t plus c e to the t. Now this is your simplified version of the general solution. Okay? Now this is just the method of integrating factors in a nutshell. Essentially what you do is first find your integrating factor or your mu term, multiply through the equation with your mu, as we did right here, and then you'll see that the left part ends up looking like a derivative of the product rule. And I do urge you to try to do this on your own. And to try to take the derivative of e to the negative t times y. All right? Again, if you have any questions regarding the calculus or algebra aspects of what I did, please let us know in a message and we'll make a video just for you.